Hello, here to present the project MEDEXTRACT ICD NLP-powered medical condition extraction and ICD-10 mapping. The project presentation holds these contents. Medical coding is essential for healthcare documentation, billing, and research. Manual coding is time-consuming, error-prone, and inefficient. MEDEXTRACT ICD automates medical condition extraction and ICD-10 mapping using NLP. Leverages the N_BC5CDR_MD model for named entity recognition, NER. Integrates with UMLS API to retrieve ICD-10 codes. Streamlines workflows with a user-friendly Streamlit-based interface. Enhances accuracy, reduces human effort, and ensures standardized classification. Manual medical coding is slow, inconsistent, and error-prone. Misinterpretation leads to incorrect classifications, claim denials, and financial losses. Unstructured clinical text (DHRs, doctor's notes) is difficult to process manually. Inconsistent medical terminology and abbreviations complicate coding. Increasing demand for real-time, accurate, and automated medical coding solutions. Lack of scalable NLP-driven systems for extracting conditions and mapping ICD-10 codes. Need for a system that minimizes human intervention and improves coding efficiency. Extracts medical conditions from clinical documents, TXT, PDF, DOCX. Maps conditions to ICD-10 codes using NLP and UMLS API. Supports manual text entry and bulk document uploads. Provides real-time ICD-10 code retrieval via an intuitive interface. Useful for hospitals, insurers, researchers, and medical coders. The methodology consists of 4 main phases: text extraction, medical condition extraction, API mapping, and ICD-10 code retrieval and output generation. Text extraction phase. The first step involves extracting text from TXT, PDF, and DOCX files. Technologies used: Plumber for parsing text from PDFs, Python docs for extracting text from Word documents, UTF-8 decoding for handling plain text files. The extracted text undergoes pre-processing to remove unwanted symbols, INE breaks, and formatting errors. If no text is detected, the system prompts the user to upload a valid document or enter text manually. Medical condition extraction phase. Extracted text is processed using named entity recognition, NER, to detect medical conditions. Technology used: Spacies N_BC5CDR_MD model, a biomedical NLP model trained to recognize diseases and disorders in text. Steps in this phase: the NER model scans the text and identifies medical conditions. Extracted conditions are stored in a structured format. Duplicate entries are removed for accuracy. If no conditions are detected, users are prompted to review the input text. API mapping phase. Extracted medical conditions need to be standardized using the Unified Medical Language System, UMLS. Technology used: UMLS REST API to retrieve concept unique identifiers, CUIs, for each condition. Steps in this phase: each extracted condition is sent to the UMLS API search endpoint. If a CUI is found, it is stored alongside the condition. If no CUI is available, the system flags the entry for manual review. This ensures terminology standardization, making extracted conditions compatible with international medical coding systems. ICD code retrieval and output generation phase. Once medical conditions are mapped to CUIs, they are used to fetch ICD-10 codes. Technology used: UMLS API ICD-10 mapping endpoint to retrieve corresponding ICD-10 codes. Steps in this phase: the system queries the UMLS API using the CUI. If a match is found, the ICD-10 code and description are stored. If no match is available, the system indicates that no mapping exists. The final results are displayed in a user-friendly interface and can be downloaded in CSV, TXT, or JSON formats, allowing integration with healthcare systems. This is the architectural diagram of the project. You can relate it with the method above. Here comes the flow diagram. Next we have the tech used, model used, and _BC5CDR_MDE, a pre-trained biomedical named entity recognition (NER) model, specifically designed for identifying diseases and disorders in medical text. Library, built using Spacy, one of the most efficient NLP frameworks. The N_BC5CDR_MD model was trained on the BC5CDR, Biocreative v Chemical Disease Relation, corpus, which consists of biomedical text from PubMed articles. The dataset includes 1,500 abstracts manually annotated for diseases and chemicals, 4,409 disease mentions, and 5,203 chemical mentions. API used, UMLS API, a service provided by the National Library of Medicine, NLM, that enables access to medical terminologies and mappings. Concept Unique Identifiers (CUIs) are used in the Unified Medical Language System (UMLS) to uniquely identify medical concepts, such as diseases, drugs, and procedures, across different coding systems, ICD-10, SNOMED-CT, MESH, etc. Streamlit for user interface. Requests for API calls. Spacy for NLP-based medical condition extraction. Plumber for extracting text from PDF files. Python docs for extracting text from docx files. IO for handling file input-output. Pandas for data handling and exporting results. We have used these in the code. This will be the output interface. The system successfully extracts medical conditions from clinical text and maps them to their corresponding ICD-10 codes with high accuracy. Effective error handling ensures that invalid or non-medical inputs are identified, preventing incorrect outputs. Manual validation confirms that extracted conditions match online medical references, ensuring reliability. Model testing verifies the precision of condition extraction, minimizing false positives. API mapping test confirms seamless integration with UMLS API, ensuring correct ICD-10 code retrieval. MEDEXTRACT ICD streamlines the process of identifying medical conditions and assigning ICD-10 codes, reducing manual effort. The combination of Spacy's NER model and UMLS API ensures efficient and accurate mapping of conditions. The user-friendly interface allows healthcare professionals to extract, map, and export medical conditions effortlessly. Developing multilingual NLP models to support non-English medical texts, expanding the system's usability across global healthcare settings. Extending compatibility to various medical coding standards, SNOMED-CT, LOINC, ICD-11, and supporting multiple file formats, PDF, docx, HL7, FHIR, for seamless integration. Implementing OCR-based handwritten text recognition to extract medical conditions from doctors' handwritten notes, improving accessibility in clinical settings. Enhancing accuracy using a multi-model approach by integrating rule-based methods, deep learning, and transformer-based models, reducing errors and improving precision. In summary, while the project has established a strong foundation for intelligent extraction and mapping of ICD-10 codes, there remains considerable potential for enhancement and growth, which can be pursued through further research and development efforts. Goals. Goal 3. Good health and well-being. MEDEXTRACT ICD enhances healthcare by improving the accuracy and efficiency of medical coding, leading to better patient care and outcomes. Goal 8. Decent work and economic growth. By automating manual coding tasks, MEDEXTRACT ICD increases productivity in healthcare, contributing to economic growth and job creation in healthcare IT. Goal 9. Industry, Innovation, and Infrastructure. MEDEXTRACT ICD promotes innovation in healthcare systems by utilizing advanced technologies like NLP and APIs to improve medical coding and documentation processes.